Here in this question, you can see a figure in which the ratio of some sides are given here, and angle 1 is equal to angle 2. As you can see in the figure, this is angle 1 and this angle 2 is equal. And what we have to prove here is that the triangle PQR is similar to TQR. So which is triangle PQR, as you can see, this is triangle PQR, right? This triangle we have to prove similar to triangle TQR. That means this bigger triangle, right? So this bigger triangle is TQR, and there's another triangle called PQR. The PQR triangle is this. This is PQR. So we have to prove these two triangles similar. Now we can see that as I have shaded both the figure, and I can see clearly that there is one angle which is common, right? So we can use this angle 1 as a common angle to both the triangle. But let's first use the informations given here. We can clearly see that we have angle 1 is equal to angle 2. So consider a triangle in which angle 1 and angle 2 is there. So I can see it is in triangle PQR, right? So we have these two angles as equal. As you know that in a triangle, if two angles are equal, then the sides opposite to these angles are also equal. Means to say that we can say that since these two sides are equal, then these two angles are equal, then this side, right, which is will be equal to this side, right? This is called by using the properties called sides opposite to equal angles. So let's start with the working. We can first consider the triangles here. The triangles which we'll be considering is in triangle. We have taken the triangle PQR. In this triangle PQR, we are given angle 1 is equal to angle 2. So therefore, by using property, we can say that PQ is equal to PR, right? This is equation 1. The other information which is given to us is this. The other information is this. So this ratio between the sides, I'm writing it down. Now say what we have, this is a QR upon QS is equal to QT over PR. Let's understand this. We are given this QR. As you can see, this is QR over QS. This is QS is equal to QT, this thing whole QT over PR. That means this is. Now, it does not give an idea unless we use both the information we got. What in case if I replace here, if we replace this PR with PQ as we have proved it equal. So let's say if I replace it, what is the result here? It's after replacing what we can get from this second equation and the first. That means in replacing PR with PQ in the second equation, what do we have? It is QR over QS being as it is, QT also same as it is. I'm replacing PR with PQ. And say if I write it, equation say 3. Now you will see that we have actually proved two sides of the triangle that we need to prove similar as proportional. If you look into this part, you'll find that we have proved the two sides proportional for the triangles that we have to prove similar. Now, let's say how to prove it similar further. Let's consider once again the triangle which we have to prove similar. So I'm writing the triangles that we have to prove similar. That means here, right? In triangle PQR and the other triangle, that is triangle TQR. So first I can write, as I said in the beginning, we have one angle, angle 1, which is common to both the triangles. So I can simply write angle 1 is equal to angle 1, and that is common. And the second one is this equation 3, from where we have already obtained the sides as proportional. That means QR over QS is equal to QT over PQ. Let's understand once again what we have done as of now. We have proved QR being the part of the bigger triangle over QS being the part of the smaller triangle, right, is equal to QT being the part of the bigger triangle, and QP, that's PQ only, being the part of the smaller triangles. As you can see that we have proved the two sides proportional and their included angle as equal. So we can say that the triangles are similar. Now we can straight away write the triangle. This is PQR is similar to triangle TQ, as PQR is similar to triangle TQR, and the criteria here is SAS similarity is what. So this is how this question can be done. So always remember that in order to prove these two triangles similar, we first start with the isosceles property. That means considering a triangle, this triangle PQR, where we proved angle 1 is equal to angle 2 first. Once these two angles are equal, we wrote their sides as proportional, and replacing this PR with PQ, we got two sides proportional for the triangles to be proved similar. So once two sides of the triangle are similar and the included angle, if it is equal, then the triangles are similar by the property called SAS criterion.